Okay, so we'll move on to the next part. The next part of the lesson is trigonometric and hyperbolic substitutions. Okay, so we are going to learn how to use substitutions and what type of substitutions we can use. Okay, now they have said here. Now for questions like this. Okay, so now these 8, 9, 10, 11 are the results that we discussed already, that we used already, right, in the previous exercise. So they say in these kinds of questions, now if you want to use a substitution to get the answer for this, they say that using algebraic substitution such as u equal 1 minus x square. Now say you want to do the proof of this. Okay, so if you want to do the proof of this particular integration, they are saying you if you use a substitution such as u equal 1 minus x square, it will not help you. You can try and see it will not help out at all. So what we need to do is we need to use a suitable, we need to use an appropriate trigonometric or hyperbolic substitution. So what they are doing in this part of the lesson is they are teaching you how to decide on an appropriate substitution. Now look at the substitutions they are given you. For an integral involving root 1 minus x square, they are telling you to try x equals sine theta or x equals tan u. For an integral involving 1 plus x square, try x equals tan theta or x equals sine u. For root 1 plus x square, they are asking you to try sine u or tan theta. For root x square minus 1, they ask you to try cos u or sec theta. So let's see what they are asking us to do. So when they ask you to use substitution now in an event, in a question, they ask you to use an appropriate substitution and do the sum. Then you must know if you have integral involving this, you have to use this particular substitution. Okay, so shall we try a sum? Okay, so let's try a question here. Before the sum, actually, we need to write down this part. Make a note of this, children. So for the integrals of the form, integration of 1 over root a square minus x square. Do you see that these four rules are actually the same previous rules? Can you see? The previous rules I have discussed over here, but what's the difference between 8, 9, 10, 11? And between these, what they have given? Do you see that they are almost the same? There's one small difference. What is it? Here you have 1 minus x square. Here you have a square minus x square. Here you have 1 plus x square. Here they have a square plus x square. Do you see it's exactly the same thing? It's almost the same thing, just that a is replaced instead of 1. We have a value here. Okay, so then what we'll do is we'll remember this, because in the case where a becomes 1, we go back to the previous rules, right? So this is a general way to remember. So they have told you the best substitutions to use. So for 1 over root a square minus x square, the substitution is x equals a sine theta. For 1 over a square plus x square, the substitution is x equals a tan theta. For 1 over root a square plus x square, the substitution is a sine u, and for 1 over root x square minus a square, the substitution is a cos u. So make a note of this, because according to the type of sum, so we will choose the substitution according to this and we will do the sum. Okay, so make a small note of this. Okay, and then they have given you these results. Okay, the following results are given in the Excel formula booklet. So basically, in the first step that I showed you, we did from rule 1 to 11, right? So this is the rule number 12, 13, 14, and 15. Basically, 12, 13, 14, 15 is exactly the same. I mean, almost the same from 8 to 11. Just that the one is when a becomes 1, it becomes the rules from 8 to 11. Are you with me? So basically it's the exact same thing, but just that you have a square, you have a value here. Okay. So make a note of these rules as well. We are allowed to use these rules immediately. If they have asked you to get the integration, immediately you can use. Or else if they want a substitution, then you can use these substitutions appropriately and get it done. Okay, so let's go for the sums. Okay, so we'll go to exercise 4C, question number 1. Okay, in exercise 4C, they say unless a substitution is given or asked for, use standard results 8 to 15. Are you with me? So unless they ask you to go for a substitution, you are allowed to use the standard results. Okay, give numerical answers to trigger set unless otherwise stated. Okay, so let's start with this one. Okay, so question number 1, they say use the substitution x equal a tan theta to show that the integration of 1 over a square plus x square dx is 1 over a arc tan x over a. Shall we try this? Okay, so question number 1, part A. The integration, we are trying to integrate 1 over a square plus x square with respect to x, and our substitution is x equal a tan theta. The substitution is x equal a tan theta. So whenever they give you a substitution, what's the first thing we do? We must differentiate the given substitution. So what do we get here? Dx by d theta. A times, what's the differentiation of tan theta? Tan differentiation is, so this is trigonometric. Differentiation of tan is sec square. So then let's make dx a subject. Dx equals a sec square theta d theta. Are you with me? So let's input the value here. 1 over a square plus x square times dx is a sec square theta d theta. Okay. So let's input the values here. 1 over, again let's replace the x with x is a tan theta. So x square should be a square tan square theta. So on top you have, shall I write on top? On top we have a sec square theta. So let's take the a square out. 1 over a square, I'm going to take it out. Then I get here 1 plus tan square theta. 1 plus tan square theta. So who is 1 plus tan square theta? Yeah, we can take a also and actually cut 1a here, right? A is a constant, so we can cut it. Who is 1 plus tan square theta? Sec square theta, right? 1 plus tan square is sec square. So do you see here the 1 sec square cancels? And we get what? 1 over a integration of just 1. So what happens when you integrate just 1 with respect to theta? We get theta. Okay, now who is theta? Let's go back to our starting place. So we used x is a tan theta. Let's get the value of theta. So x over a is tan theta. Then theta is tan inverse, or in other words, arc tan x over a. So I can replace theta with arc tan x over a plus c. So isn't this the show that? Isn't this the show that for 1 over a square plus x square? Can you see the rule? Rule number 13. So we practically proved rule number 13. Can you see? Okay. Then let's try another one. That we'll use suitable substitutions. Okay, so in use suitable substitution, like in question number 3, we need to. Okay, we'll do question number 3. Okay, so we'll go to question number 3. Use suitable substitutions to find the integration of 3 over root 4 minus x square. So they say here to you clearly to find suitable to find the integration using the suitable substitution. Are we directly allowed to integrate here? No. So then. Let's go. Which one is suitable? So I have written the rules. These are the rules. Which rule am I using? 1 over 3 over. So of course 3 we can take it out. There's no problem. Which one? We can go with the very first one, right? So 1 over root a square minus x square. So what's the substitution we should use? So I can take the 3 out. Okay. So 1 over root 4 minus x square. So then we can use here. What is your a value? A is now here, 4 is the a square value, which means a is 2. Are you with me? So then the substitution that we use is, let's use substitute x equals, a is 2 here. Do you realize? 2 sine theta. So when you are doing substitution, the normal rules are applying. Now let's differentiate. Dx by d theta equals 2 sine theta. Differentiation is cos theta. So let's make dx a subject. Dx equals 2 cos theta d theta. Let's substitute. So here 3 times integration 1 over root 4 minus, shall I input here because nothing will cancel out. X square will be what? If x is 2 sine theta, x square will be 4 sine square theta into dx. Dx is cos theta d theta. Are you with me? So then here 3 times integration, the 2 I can take it out again with 3, right? So it becomes 6 cos theta. From here, from the square root, 4 is common, right? Shall I take 4 out? So when I take 4 out, it can even come out of the root becoming what? 2. So I'll take 2 down. And I have inside the root 1 minus sine square theta and the d theta. Okay, this 2 went out with the 3 and multiplied. Here the 4 came out of the root. 4 is common, so it can come out of the root as a 2. Okay, so I get here 6 over 2 is 3. Integration of cos theta. Root 1 minus sine square is cos square, right? Root 1 minus sine square is the cos square. So root of cos square is cos theta. Do you agree? I've skipped a few steps here. Root 1 minus sine square. The 1 minus sine square is cos square. Root of cos square, when you remove this root and the square will cancel and you get cos theta. So basically again the cos theta will remove and you get the integration of 1. So when you integrate 1 with respect to theta, we get theta. Don't forget the plus c. Now get the theta value. How is theta? X is input from the main substitution. X is 2 sine theta, which means x over 2 is sine theta. X over 2 is sine theta, which means what? Theta is sine inverse x over 2 or arc sine x over 2 equals to theta. So basically this is 3 arc sine x over 2 plus c. Okay, can you understand? Part D. Let's try again the same process for part D. Integration of 1 over root 4x square plus 25. So what do we get here? Once again, what's the substitution to use for 4x square plus 25? Root 4x square plus 25. Now you can see here none of the, in all of these rules, do you see x square is independent? I mean, we don't have any 2x square or 3x square, anything like that. So first thing is you have to make sure that this follows this format. So to follow this format, we can't have a 4 with the x square. So what do you have to do? Take the 4 out. Let's take the 4 out first. So integration 1 over, I'll take the 4 out inside the root first. So inside the root, I don't want this x square to have a 4. The x square needs to be alone according to the format because otherwise I can't use these rules. So when I take a 4 out, what is remaining here? X square plus, I'm taking a 4 from both of these guys. 25 over 4. Do you see what I did here? And then what I can do is now, I can take the 4 out of the root because this 4 is inside this root. Do you see? I have a square root here. So I can take this 4 out of this root. It comes as a 2. And then inside the root we have now x square plus 25 over 4. Are you with me? So this is basically half. Integration of 1 over root x square plus 25 over 4. Okay, so now let's look at these rules. Have a look at the rules again. Which rule should I use here? 1 over x square plus a square, right? Which one? The third one. The one I have outlined in red. So the one I have outlined in red is if you have root a square plus x square. You see we have plus mark. So we have to use what? X equals a shine u. Are you with me? So here what's our a value? Now here a square is 25 over 4. Which means a will be how much? 5 over 2. So the substitution we use is substitute x equal a shine u. A is 5 over 2. Shine u. So this is why I got it from those rules that I gave you all earlier. Okay, so let's whenever we differentiate, when we substitute, we must differentiate the substitution. So dx by du equals 5 over 2. Shine u differentiation is directly cos u. So dx equals 5 over 2 cos u into du. Okay, now let's substitute. Half integration 1 over root x square. X is 5 over 2, right? 5 over 2 shine u. So when you square 5 over 2 shine u, you get 25 over, you get 25 over 4 shine square u. Plus there is a 25 over 4 here. Into what's our dx? 5 over 2 cos u du. Okay, so then we get here, let's simplify half. I can take 25 over 4 out as common, right, from this root. So then 25 over 4 is a perfect square. I can take the 25 over 4 from both the elements out and it comes out of the root as what? Do you understand that I can take it immediately out of the root? And I just end up getting here shine square u plus 1. Do you get what happened here? I mean, I took the 25 over 4 commonly out from both of them and I also took it out of the root and it became 5 over 2. Okay, and then here I have into 5 over 2 cos u du. So if you can see here, the 5 over 2 to 5 over 2 will cancel out. Who is sine square u plus 1? We know our identity is cos square u minus sine square u is 1. This is the hyperbolic identity. So 1 plus sine square is 1. 1 plus sine square u is cos square u. So 1 plus sine square is cos square u. So cos square u when we integrate, cos square u when you take the root, you get simply cos u. And you can see on top also we have cos u. Then I can cancel cos u. Cos u is, you can see here simply what I get integration of just 1 with respect to u. So half integration of 1 with respect to u is u plus c. Now it's time to input back the u value. What was our main substitution? The main substitution is x equals 5 over 2 shine u. Can you see? So x equals 5 over 2 shine u. Take it to the other side. So I get here 2x over 5 equals to shine u. Which is what? U equals to shine. Taking the other side, it's R shine, right? R shine 2x over 5. Are you with me? So now replace here. This is half times R shine 2x over 5 plus C. Okay, question number 4. Write down the results for the following. So when they say to write down the results, do we need to use any substitution? Have they asked you to use the substitution? No. So you're directly allowed to use these results that they have given. So let's directly use it. Fourth one, part A. Integration of 1 over root 25 minus x square. Okay. So which rule does it fall number? Rule number 12, right? Root a square minus x square. So you can see here, your a value is what? A square is 25, which means a is 5. So when we use the rule, we get here arc sine directly x over a is 5 plus c. That's it. Simple as that. Part D, integration of 1 over 16 plus x square. So once again, which rule are we working with? 1 over 16 plus x square means this is rule number 13, right? Rule number 13. So in rule number 13, how does it work? The a value is a square is 60, which means a value is 4, right? So it gives us how much? 1 over 4 arctan x over 4 plus c. Are you all with me? Go to the fifth question. Fifth question, part A, integration of 1 over root 4x square minus 12. Write down. Okay, now can I use any of these rules in when we have x in this particular format? No, because you can see in all these rules, it's just x squared. It doesn't have any other coefficient with it. So you have to get rid of the 4 first of all. Get rid of the 4. So when you remove the 4, inside the root. What do we get here? X square minus 3. So you can take the 4 out of the root, it comes as a 2. So basically it becomes a half. 1 over root x square minus 3. Okay, so then who is this? The 3 is your a square value. Remember 3 is your a square, which means a is root 3. So which rule are we working with? Root x square minus a square is 15th rule. Root x square minus a square is r cos x over a. So put r cos x over a. So there's a half outside, don't forget, half r cos x over a. A is root 3 and plus c. Okay, can you understand? Do part D. Start part D. Okay, part D. Integration of 1 over root 3 minus 4x square. Okay, do we have a rule with a square minus x square, by the way? Yeah, there is a rule with a square minus x square, right? Can you see? So basically what I'll do here is I'll need to have only the x square here. I'll need to remove the 4 with the x square. So do the exact same thing. 1 over inside the root, you take a 4 out. Are you with me? So when you take a 4 out, 3 becomes 3 over 4 because you divide by 4 minus x square. Are you with me? So the 4 comes out of the root as a 2. So it's in the denominator. So therefore, it's 1 over 2. Integration of root 3 over 4 minus x square. Okay, so then this is our a square. So our a square value here is 3 over 4, which means a value is root 3 over 2. So let's input the equation. So we have here half. The integration of this is arc sine x over a. So arc sine x over a is root 3 over 2. So half arc sine 2x over root 3 plus c. Question number 6, they ask you to evaluate, and do you see the only difference is in sixth one, they have given you limits. So how do we evaluate? Sixth one, part A, integration of 2 over 1 plus x square within the limits 1 to 3. So what happens? The 2 comes out, integration of 1 over 1 plus x square gives you what? So 1 over 1 plus x square, basically here now your a value has become 1. It's rule number 13, right? Rule number 13. So when you integrate, keep the 2 there. So it's gonna be 2 into rule number 13 is 1 over 1. 1 over a is 1. Arctan x over a, which is basically x over 1. Are you with me? And your limits are from where to where? 1 to 3. Let's input the limits. 2 times arctan 3 minus 2 times arctan 1. Okay, so in this case, you can type tan inverse 3 in the cal, tan inverse 1, and you will be getting a decimal answer, right? So they're asking you to evaluate. This would be the exact answer, but if you type in the cal, you can get the decimal. Can I know the decimal answer here? 0.927, correct to 3 significant figures, right? Okay, let's do something like question number 7. Now, this is what you mostly get in your exam. See, evaluate the following, giving your answers in terms of pi or as a single natural logarithm, whichever is appropriate. So this is more likely what you get in your exam. Like we are more used to giving what answers? Exact answers. So let's move on to question number 7 because that's more of what we need to practice. So 0 to 4, 1 over root x square plus 16. First of all, do you see which rule to use? X square plus root x square plus a square. Root x square plus a square is rule number 14. Root a square plus x square. So what's the answer here? It's r sine x over a is 4, right? A is 4. R sine x over a. Okay, so then let's input the limits. 0 to 4. Input the limits from 0 to 4. So continuing with the limits, let's input our limits here. R shine x is 4, right? So 4 over 4 minus R shine 0 over 4. So basically we get R shine 1 minus R shine 0. So I have written the formula we use in chapter 1. We learned this particular equation, right? It's there even in your formula books. R shine x is equal to ln x plus root x square plus 1, because they have asked in this question to give the answer in terms of pi or as a single natural logarithm. So by using this equation, we can give our answer as a single natural logarithm. So giving our answer finally, ln R shine 1 means x is 1. ln 1 plus root 1 square plus 1 is root 2 minus R shine 0 ln 0 plus root 0 square plus 1 is root 1. So basically I end up getting here ln 1 plus root 2 minus ln 1. ln 1 is 0. Root 1 is 1, ln 1 is 0. So this is our answer, ln 1 plus root 2. So the next one, part C. Integration from root 2 to root 3, 1 over root 4 minus x square. So this one, root 4 minus x square, we can use rule number 15, root x square minus a square. So when I use this, what do I get? We can directly use, your a value is actually what? A square is 4, which means a is 2, right? Let's use the equation. So the equation is r cos x over a is 2. Are you with me? And our limits are from where to where? Root 2 to root 3. So what do we get here? R cos root 3 over 2 minus r cos root 2 over 2. So r cos x, can I know the equation for r cos x? Similar to r sin x, we also have a rule for r cos x in the formula book. R cos x equals ln yeah, so I have used yeah, this should be x, not x square minus a square. We should use a square minus x square. Yes. So we don't need to go for this. Let's quickly fix it. Okay, so I use the rules correctly. Okay, so I have to use root a square minus x square, rule number 12. Yeah. So that gives me arc sine actually. Arc sine x over a is x over 2. Is that okay now? And our limits are from where? Root 2 to root 3. Okay, let's input the value of arc sine root 3 over 2 minus arc sine root 2 over 2. Root 3 over 2, sine inverse root 3 over 2, it gives the answer in terms of pi, right? Pi over 3 minus arc sine root 2 over 2 is pi over 4. Pi over 3 minus pi over 4 is pi over 12. That's why they have told to give you answer either in terms of ln or in terms of pi. Okay. By splitting up each integral into two separate integrals or otherwise, find the integration of x minus 2 over root x square minus 4. So split this up. What do you mean by splitting it up? Because we can't immediately integrate, right? So when you split this up, what do we get? So x minus 2 over root x square minus 4. So when we split, they have told you to split it. So what do we do here? This becomes integration x over root x square minus 4 and minus 2 over root x square minus 4. Is that okay? Okay, now we have to think of the integration rules. Okay, so we have here, so we are going to integrate this now. Okay, so to integrate this, first of all, can we use any of these known rules here? Yeah. No, right? No, none of these, because there's x on top. When there's x on top, these rules don't work. So then what do we need to do here? We need to use what rule? Can I use f dash x over fx? That also doesn't work because there's a root. So the only thing that works here is what? Take the root x square minus 4 up. So when you take it up, what do you get? X times x square minus 4 to the power minus half. Okay, and this one, the other guy, do I need to fix anything, take it up? No, because the second guy is just having a 2 on top, so it can fit into one of these formats. Root x square minus 4 can fit into the 15th equation, right? Can you see 1 over root x square minus a square? It fits into that. So we don't need to do anything to that guy. So that guy can stay exactly where it is. I'll integrate everyone together at once. So here, now to integrate this guy, oh no, shall we separate it, the integration? Let's separate the integration. So this guy integrates separately and this guy, because it's better to have the integration separately. So we'll integrate the two separately, okay? Yeah. Right. So now here to integrate this guy, can I directly integrate this? F dash x, fx to the power n, right? So this is my fx. So what should be the f dash? X square differentiation is not just x, but 2x. So to cancel the 2, we have to put a half in front. Okay, so that's why I separated this guy. I thought of writing this out separately. Otherwise, the other half, you would confuse it with the other person. So to have the two people clearly separated. So then this 2.5 is only there for this term. Okay, are you looking at this? So what's happening here? We get half times x square minus 4 to the power minus half. We add 1 to the power, right? X square minus 4 minus half. You add 1, you get plus half. Also, divide by half, fx to the power n plus 1 over n plus 1, right? Minus, here the 2 can stay in front. 1 over root x square minus a square is what? R cos x over a. A square is 4, a is 2. Are you okay with it? So here the half to half can cancel. X square minus 4 to the power half minus 2 times r cos x over 2 plus c. So this is the answer for 11th question. Okay, so this is, we split and we do the sum. Okay, so I think the other parts in question 11 are like exactly the same. Shall we move on to question number 16? 16 part A. Okay, in question 16A, use the substitution x equal 2 cos u to show that, okay, to show that the integration of root x square minus 4 can be written in this manner. Okay, so we have to do the integration of root x square minus 4 with respect to x, right? This is the question, and the substitution is what? We are supposed to substitute x equals to 2 cos u. Okay, so first step in substituting is what? Replacing the, first step in substituting is differentiating the given substitution. So we get here dx over du equal to cos differentiation is sin u. Okay, so we get here dx equals 2 sin u du. Is that okay? So let's input the, let's substitute the values we found. X square minus 4 dx is 2 sin u. So x square is 2 cos u. So when you square it, we get 4 cos square u minus 4. Into 2 sin u du. Are you okay with it? So from here I can take the 4 out directly. I'll take it directly outside as a 2. Is that okay? This is cos square u minus 1 into 2 sin u du. So I end up getting here, the 4 comes in front. Sin u root cos square u minus 1. So then I get here, I take the 2 and 2 multiply to give me 4 sine u root cos square u minus 1. Who is cos square u minus 1? You know cos square u minus 1 is sine square u, right? So sine square u, so root sine square u gives you sine u. So basically this gives you 4 times integration of sine square u du. The in here cos square minus sine square is equal to 1. So cos square minus 1 equals to plus sine square. So this is correct, right? So I have the integration of sine square. Okay, how do I integrate sine square once again? Okay, we need to get this, show that also. So how do we get the, how do we integrate sine square u? We use the help of double angle rules, right? So what's the double angle rule we use? Cos 2u is what? 1 plus 2 sine square u. Do you agree? So then so cos 2u minus 1 over 2 equals to sine square u. Is that okay? So 4 into integration of cos 2u minus 1 over 2 into du. So 4 over 2, I can take 2 out, it cancels. So 4 and 2, we can simplify 2 times cos 2u minus 1. So cos integration is, what is the cos integration? 1 over 2 sine 2u minus integration of 1 is u. So do we have any limits? No, right? Plus c. Okay, then let's multiply. 2 into half is 1 sine 2u minus 2u plus c. Okay, let's input the values. So they have given the answer in terms of x, right? So what did we use for? We use x is 2 cos u, isn't it? X is 2 cos u. The answer you need to give it in terms of x. Okay, because we use the substitution here. So how do we replace sine 2u? We know sine 2u, we can use the double angle rule. Sine 2u can be written as 2 sine u cos u. This is the double angle rule. Minus 2u. Let's input. So if we can use the rule cos square u minus sine square u equals 1, right? So then cos square u is x over 2. Can you see cos u is x over 2? Which means cos square is x over 2 whole thing square. Minus sine square u equals 1. I get here x square over 4 minus 1 equals to sine square u. Are you okay with that? So I get sine u equals to root x square over 4 minus 1. So here let's substitute the value. 2 times sine u is root x square over 4 minus 1 into cos u is directly x over 2, right? Cos u is directly x over 2 minus 2u. Okay, I need to fix u also. I didn't make u the subject. Let's make u the subject here. X over 2 is equal to cos u, which means who is u? U is equal to r cos x over 2. Is that okay? In the show that have they simplified? In the show that they have, yeah, they've simplified, right? So let's simplify here. 2 times x square minus 4 over 4 minus 2 times u is r cos so 2 plus c. So I can take this 4 out of the root because 4 is a complete square number. We can take it out as a 2. I mean, basically it comes out as a half. It comes from the denominator. So here the 2 is there already and the 4 from the denominator comes and we have root x square minus 4 into x over 2. So I'm writing some extra steps here, but you can skip them, no problem. So the 2 and 2 cancels. Basically, I have half x times root x square minus 4 minus 2r cos x over 2 plus c. Okay, so these are show that, right?